Welcome to our video on the quote of ratios. Just like grammar gives structure to language, ratios give structure to how we compare things. By the end of this, you will be able to measure and translate quantities into meaningful numbers. A ratio simply compares the relative size of two quantities. The word per acts as a signal for division. Ratios translate raw numbers into relationships, like miles per hour or dollars per can. Imagine a grocery store dilemma. You have two different bundles and need to find the best value. By calculating the unit price using division, we can compare these bundles objectively. The order of division changes your perspective. Dollars per can tells us the cost, where lower is better. Cans per dollar shows us value, where higher is better. Both help us find the best buy. This is the Rosetta Stone of ratios. Different formats like 12 to 15, fractions, and decimals all represent the same relationship. Converting to a decimal is useful because it simplifies the comparison against one. Use this conversion table as a recipe. Start with the ratio, write it as a fraction, reduce it, and then divide to get your decimal. If the division doesn't end, rounding is perfectly acceptable based on the context. Rule number 1, units must match before they can combine. We use a conversion layer to ensure we are comparing compatible units, like inches to inches. Remember, the first item mentioned always goes on top. Here is a helpful shortcut. When both quantities end in 0, you can cancel them out symmetrically. This gives you a smaller, easier fraction to reduce, like turning 60 over 100 into 3 over 5. Rule number 2, equivalence requires perfect scaling. If we look at different aspect ratios, we can see they don't overlap. Mathematically, if the division yields different multipliers, the ratios are not equivalent. Rule number 3, ratios scale symmetrically. If you are adjusting a recipe, as long as you apply the same scale factor to both the numerator and the denominator, the relative balance of your ratio is perfectly preserved. Let's look at the denominator flip. Whether we calculate treats per dog or dogs per treat, the order changes the meaning. Whichever quantity you list first becomes the numerator and sets the narrative. Applying these rules, we can quantify inequality, such as comparing wages. By setting up the ratio and reducing it, we can determine exactly how much one person earns for every dollar earned by another. In conclusion, a ratio is not just a fraction, it is a lens. By deliberately choosing which quantity sits in the numerator, you control the story the data tells. The math is objective, but the perspective is yours.